Okay, welcome everybody. I've got 10:30 a.m. Eastern Daylight Savings Time. This is your host, Jennifer Brennan. I'd like to welcome you to the NASA Earthdata webinar, Discover NASA Near Real-Time Data Using LANCE. So while everybody is logging in, some of you have already seen this, I see. We have two polls at the bottom of the page, in the left and the middle of the page, that we'd like for you to take a moment to fill out. That would be much appreciated. This is your host, Jennifer Brennan. As I mentioned, I am the NASA Earth Observing System Data and Information System, or EOS-DIS, User Support and Communications Lead at NASA Goddard Space Flight Center, and also your host today. So I'd like to begin by going over a few housekeeping items related to this webinar. First, due to the large number of participants and also to ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or questions, what you can do is you can enter those into the Q&A pod here in the lower right-hand corner of your screen. This does work like a chat. Okay, the webinar itself will be recorded and posted to our NASA Earthdata Adobe Connect catalog, as well as to our NASA Earthdata YouTube channel. I will provide the URL on the contact slide at the end. All presentation files will be available for download at the end of the webinar. The webinar itself is 1 hour long. We've allocated 45 minutes to the presentation and live demonstration, and then another 15 minutes or so for the question and answer period. After the speakers have finished their presentations, we will then move to the final set of polling questions. And just to let everyone know, the question and answer period actually comes after the final set of polling questions. So do be sure to stay on the line and or stay in the room during that time period. As I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar, except during the live demonstration by using the Q&A pod. Due to the large number of participants, questions will not be answered using the raising hand function. It has been disabled. However, we will take all the questions at the end. One final note, depending upon the volume of questions that we receive at the end of the webinar, I will extend the Q&A period an additional 15 minutes to 11:45 a.m. for those of you who wish to stay on the line. So I'd like to move next to the agenda. I'll pull this up here for you. The first 10 minutes or so, our first speaker will provide you with an introduction to the LANCE project and available near real-time data products. During the next 30 minutes or so, we will switch over to the live demonstration where you will be provided demonstrations for LANCE, the near real-time interface, the firm's email service alert, Gibbs, and also Worldview. We do have a guest speaker today who will be demoing the Worldview interface, and that will be Ryan Bowler, and I will introduce him a little bit later as well. It is my pleasure to introduce our first speaker today, Diane Davies, who is the Operations Manager for NASA LANCE. Diane?
Thanks, Jennifer. Okay, thank you very much. So I'm going to be talking about how you can discover NASA near real-time Earth science data by using LANCE. And LANCE stands for the Land Atmosphere Near Real-Time Capability for EOS. So NASA is well known for providing high-quality satellite data for long-term science research. But application users, operational agencies, and even researchers often need data much sooner than routine processing provides. So to meet these needs, NASA developed the Land Atmosphere Near Real-Time capability for EOS. LANCE provides over 70 imagery and data products from 4 instruments, from AIRS, MLS, MODIS, and OMI. And I'll come back to these acronyms in a little while. So LANCE products are used in support of the following applications: air quality, dust storms, fires, vegetation for agricultural monitoring, floods, ash plumes, drought, smoke plumes, sea ice, and severe storms. So in this webinar, I'm going to provide an overview of an introduction to LANCE, describe a little bit about the difference between the near real-time and the standard products, what data are available, and describe the services you can use to access these near real-time products. So you can download the data, you can get fire data from firms, and imagery data from Rapid Response, Worldview, and GIBS, or the Global Imagery Browse Services. But let's start by looking at the origins of LANCE. So the first request for near real-time products from MODIS, or the Moderate Resolution Imaging Spectroradiometer, was back in 2000, not long after MODIS was launched on the Terra satellite. The US Forest Service requested MODIS fire detections within hours of acquisition to help manage the wildland fires on the Idaho-Montana border. A team of scientists from the US Forest Service, the University of Maryland, and NASA's Goddard Space Flight Center assembled a series of customized images that demonstrated the significant contribution that near real-time MODIS products could make to wildfire suppression and emergency rehabilitation. The following April, the same team initiated the Rapid Response system. Initially, Rapid Response produced data and imagery just for North America, but by 2000, the Rapid Response system was producing global imagery and data from the MODIS instruments on both the Terra and Aqua satellites. Some of the most valuable products created by Rapid Response included imagery based on the MODIS corrected reflectance algorithm, which provides true color or natural-looking images. This is an example of Hurricane Cristobal using a natural-looking image acquired from MODIS on board the Aqua satellite on August the 27th. As the Rapid Response capability became more visible, news organizations such as CNN, BBC, Washington Post, and the New York Times began requesting georeferenced images for large newsworthy events. Excuse me. Users quickly realized that the imagery and data produced by the Rapid Response system could be used for other tasks, including monitoring air quality, dust storms, snow cover, agriculture, and as well as for public outreach and education. As the original system aged and the demand and expectations for near real-time data increased, NASA's Earth Science Division implemented LANCE in 2009. So LANCE is a component of EOS-DIS, that's the Earth Observing System Data and Information System. Its goal is to provide a central point of access to high-quality, near real-time data products for land and atmosphere studies within 3 hours of satellite observation. LANCE is a virtual system. So the LANCE facilities are shown here on this map, and they leverage existing science facilities and data centers. So how do the near real-time products compare with the science products? Well, before I talk about this, I just want to define latency. Here, latency is defined as the time between satellite observation and the data being available to the end user. So for comparison, standard products have a latency of between 20 and 48 hours. To achieve the 3-hour latency requirement for LANCE, data are expedited at every step of the way, from data capture to processing and distribution. Latency requirements necessitate the use of predicted geolocation data and relaxed ancillary requirements. And in some cases, there are significant differences between the near real-time and standard science quality data products. But overall, the agreement is high. So just to break this down a little bit more, the key difference between near real-time level 0 and those for standard products are the data used to determine geolocation. So standard products use definitive geolocation or attitude and ephemeris data that's provided daily, whereas near real-time products use predicted geolocation. In the case of Terra, this is provided by the instrument's GPS or global positioning system. Aqua and Aura satellites do not have an onboard GPS, so for immediate processing, it requires spacecraft housekeeping data and predicted ephemeris. To give an idea of the impact, the difference between MODIS geolocation when using definitive versus predicted geolocation is routinely less than 100 meters. However, there are situations, particularly before and after spacecraft maneuvers and during space weather events, when the difference can increase up to several kilometers. Level 2 products can be thought of in 2 categories. The first is the level 2 products such as fire, snow, and sea ice that don't use ancillary data, in which case the algorithm is the same as the standard product. The second group of level 2 products are those that require ancillary data. These products again have inherited differences from level 0, but they also have relaxed requirements for ancillary data. So if latency is not a primary concern, users are encouraged to use the standard science products, which are created using the best available ancillary and geolocation information. And you can find the standard products through Reverb, which I'll mention shortly, or from one of the NASA's DACs, or Distributed Active Archive Centers. And you can find a list of these on the Near Real-Time website if you look up science quality products. So all expedited algorithms and any subsequent product modifications are overseen by science team members, and they're considered appropriate for near real-time applications. Okay, so what products are available? This slide highlights the product categories by instrument and the average latency times. So AIRS, or the, I think this is a little bit of echo. Is this better? So I speak close to the microphone. Okay, AIRS, or the atmospheric infrared sounder on board Aqua. There's the MLS, the microwave limb sounder on board Aura. Moda, which I've already mentioned, which is on board the Aqua and Terra satellite, and OMI, the ozone monitoring instrument, which is on board Aura. Lance distributes low-level products such as calibrated geolocated radiances and higher-level products such as active fire locations and snow cover. Originally, Lance provided data from AMSRE, or the Advanced Microwave Scanning Radiometer, but in 2011, AMSRE on the Aqua satellite malfunctioned and data provision was discontinued. Lance is currently working to ingest and process AMSA data from the Japanese GCOM-W1 satellite. Okay, so moving on to how we can discover and access the Lance products. All data and imagery are freely available. Data can be downloaded following self-registration through the EOS-DIS user registration system. For those of you that are not familiar with URS, user registration is free of charge. The user needs to set up a user ID, password, and provide a small amount of additional information, including affiliation, country, and a valid email address. Once registered, you can use this ID and password to access other EOS-DIS system components. Okay, so I'm going to describe each of these data access services in turn, starting with downloading data. So this is a screenshot of the near real-time landing page, or Lance page, which is part of the Earthdata website. And from here, you'll find links to all the services that I mentioned. So starting with download data, and by data I mean predominantly the HDF files, or the hierarchical data format. So these are data files that require remote sensing software for processing. So if you know what you're looking for, you can use these quick links on the bottom left-hand side of the page. So for example, if I'm after Moda's data, I can click there, and it will take me to this page, which provides a table of all the available Moda's products. If I scroll down, I'll also see the products from Moda's Aqua. There are 4 columns in this table. The column on the left provides a link to the FTP site, so this will take you directly to download the data. You need to be registered to be able to access the data. The second column provides a metadata description. This links through to the Global Change Master Directory. And then the third column gives you an idea of volume, and the fourth column provides a browse product if it's available. If you aren't sure what data might suit your needs, then the Hazards and Disasters page is a good place to start. All the applications I mentioned at the beginning are listed on this page. And for each hazard or disaster or application area, Lance provides a list of all the potentially useful data sets, and where possible, links to find out more about a particular event using a permalink that will take you to see the imagery for that event in Worldview, and where available, a description of the event in NASA's Earth Observatory. So if I were to click on ash plumes here, I would get a page like this. So this shows me, if I scroll down, I will see all the available data, near real-time data, that's potentially useful for ash plumes. If I scroll back up to the page, I get a link to Worldview. There's a permalink here to visualize the data in Worldview, and there's also information about this particular event in the Earth Observatory. So in this example, we're looking at the Bardarbunga volcano in Iceland, which is currently still erupting. And if I were to click on the permalink, it would take me through to Worldview. So you can see here on the left-hand side, we have a panel which shows which layers are visible. And you can see that it's showing the sulfur dioxide. It's showing sulfur dioxide. You can also visually search for data through Worldview. So if, for example, I was interested in the sulfur dioxide product, I could click on the download tab, which is also on the left-hand side, and you'll see more about this in the demonstration. And then you can see that it's searching echo for data. You can see here, this little wheel spinning while it searches echo for data, and then it will show me what data sets are available, and I can select which data set I want, and then go to here to download the data. So that's how you can visually search for the data. You can also access near real-time as well as the standard quality data from NASA Reverb. You may already be familiar with this tool. This is the EOS-DIS Metadata and Discovery tool. This slide shows the landing page for Reverb, and if you were to, on the top right-hand corner, there's a search terms box, and if I type in here MODIS NRT, then all the MODIS NRT data sets will be listed below. And you can then select the data set and the granule that you're most interested in. If you want to find out more about Reverb, it was covered in a previous Earthdata webinar that Jennifer Brennan presented called A Beginner's Tour, Discover and Access NASA EOS-DIS Data and Services. Okay, next I'm going to talk a bit about FIRMS. FIRMS stands for the Fire Information for Resource Management System. FIRMS was originally developed by the University of Maryland using funds from NASA's Applied Sciences program. So using FIRMS, users can interactively view, query, and download the entire archive of MODIS-derived active fire or hotspot data. Users can also subscribe to fire email alerts for their area of interest. FIRMS provides MODIS Aqua and Terra thermal anomalies fire locations in 1 kilometer vector format. It provides both a near real-time version, which is processed by Lance, and a standard version, which is processed by the University of Maryland with a 3-month lag. So that's only available after 3 months. And going back to what I said before, the key difference between the near real-time data and the standard version is that it is the geolocation. So it's the same algorithm, but the near real-time uses the predicted geolocation. Okay, this is the FIRMS landing page, which is also part of Earthdata, the near real-time data pages on Earthdata. And here you have options for downloading data. You can download data, either the latest near real-time data as shape, KML, or WS files, and also use the archive download tool. Okay, I'm going to just give you a few overview slides to show you how Worldview works, Web FireMapper works. You can interrogate the full archive of MODIS-derived fire data using Web FireMapper. You can zoom into an area of interest, and each of these red spots represents an active fire. If you were to use the Identify tool, you can click on a fire and get the attribute information, which I'll show you in just a minute. You also have the option of selecting a customized date. So if you're interested in fires over a particular year or couple of months over a year, then you can use this to identify those fires. If you were to click on a fire, you get the attribute information that's listed here. So this gives you the lat-long coordinates of the center pixel of the fire, the date and time at which the satellite acquired the information, and additional information such as brightness, confidence, scan, track, the satellite, brightness temperature, and FRP, which stands for fire radiative power. And you can find out more about those attributes on our frequently asked questions. I did want to include this slide though. This is also from our frequently asked questions, because if you are using the fire data, it's quite important to understand what a MODIS hotspot or active fire detection means on the ground. So each hotspot represents the center of a 1 kilometer pixel, flagged as containing one or more fires, or other thermal anomalies such as volcanoes. And we have actually been known to pick up a large barbecue in Texas. The location is the center point of the pixel, which is not necessarily the coordinates of the actual fire. And that's a mistake that some people make. They take the data as a KML file, load it into Earthdata, and then they zoom in and can't understand why it's not on one particular side of the road. So it's the center point of the pixel, and the actual size of the pixel varies with the scan and track, which is contained in the attribute information. Okay, so for WebFire Mapper, you can look to see whether fires have occurred in any particular area, but you can also sign up to our email alert service, which will notify you of a fire in any particular area. So going back to the landing page, here we are, you can see the email alerts. If I click on that, I can sign up for an alert for any area in the world using a map or selecting from a country or protected area. So if I just pause this for a second, here you can see the alerts that I'm already subscribed to, and I have the option here of managing my alerts. So I can delete them, or if I'm going on holiday for a while, I might decide that I want to deactivate the alerts. So you can select to edit them and deactivate them while you're away. Okay. So yeah, that's deactivated. If you want to create a new alert, you click on the Create button, and here you'll see a map. You can zoom in. You can also select draw your own polygon. So there's a radio button at the bottom. If you select that, hold shift and use your mouse, you can select a polygon. I'm going to clear that and just select a protected area. So the radio button at the top enables you to choose a country or protected area. So here I've chosen Australia, and it's now loading the protected areas for Australia. And I'm going to select a protected area. Here I'm selecting the Abercrombie River. I now have the option of adding a buffer in. So you might be interested to know when a fire is approaching your protected area rather than when it actually occurs there. Okay, you can type in a name for your alert, so it helps you manage them better. And then you then have an option of what size output map, whether your alert should be in English, Spanish or French, and whether you want a daily, weekly or near real-time alert. So the near real-time alerts are sent out as soon as the fire is detected. Otherwise you can have a daily or weekly summary. Okay, so you'll only be sent an email alert if a fire is detected in your area of interest. So this next slide just shows you what an email alert looks like. Here we are, you can see this is an email for Gorgonça National Park in Mozambique. And don't know how well you can read this, but here we are, there were a total of 57 fires detected in that national park over a 24-hour period. The email alert also provides you with a link to view the map on the server. Okay. I'm going to talk a little bit now about Moda's rapid response. We've already mentioned rapid response. It still continues to be available through Lance. This is an image from the gallery, the rapid response gallery. It highlights interesting events and phenomena. So this Moda's image is of the King Fire, which is still burning in the El Dorado National Forest. This image was captured on on September the 17th. And when I checked this morning, over 89,000 acres had already been burnt. So the red outline that you see indicate hotspots where Moda detected unusually warm surface temperatures that are associated with fire. And you can see here the thick smoke that the fire's giving off. Rapid response subsets remain popular amongst Lance users. Each red box that you can see here on this image corresponds to a rapid response subset. So these are user-specified, geo-referenced and subsetted images in GIS-compatible format. So for example, if I were to click on this subset here, it's for Namibia, it will take me through to a page that looks like this, where you get thumbnails showing the different band combinations that are available. So going from left to right, we see True Color, band 721, bands 367, and NDVI. And each of these band combinations is useful for showing a different phenomena. So from here, you can select the band combination and the pixel size that you're most interested in. So if I were to select True Color 1 kilometer, this is the type of image that I would see. Okay, where I've got my green arrow now, you can click on these different options to scroll through and see the different band combinations. So there I've gone to 367 and NDVI, or the Normalized Difference Vegetation Index. There's also an option of adding in vector layers. So here I'm going to add in the borders, the fires, and the coastline. There are also these links to download the image in different files, in different image formats, and also to see metadata. And on the right-hand side here, you'll see that there's an option to view this region interactively with Worldview. So Worldview provides all the features that Rapid Response has and more. Worldview is the EOS data visualization, discovery, and download tool for GIBS, and GIBS stands for the Global Imagery Browse Services. So the key features for Worldview are that it has Google-like Maps ability to interactively pan and zoom and then share permalinks with others. But unlike Google Maps, Worldview can interactively change the currently displayed time, and you can view imagery in Arctic and Antarctic polar stereographic projections. And I'm now going to turn over to Jennifer so that we can switch to our live demonstration from Ryan Boller, who's responsible for Worldview.
Okay, so thank you, Diane. Our guest speaker for the Worldview portion of the live demonstration is Ryan Boller, and he's actually the data visualization lead for the NASA Earth Science Data and Information Systems, or ESDIS project at Goddard. Ryan?
Thanks, Jennifer and Diane. So I am excited here to talk to you all about what we do with Worldview and GIBS. So my team's job is to basically take the data that we have, which is an ATF format, like Diane mentioned, turn that into imagery, and then make that interactively browsable. So the main goal of Worldview is to, in fact, interactively look for interesting data and then compare it to other data, to download it, or to share it. Basically just to explore what we have interactively. So it's a freely accessible web app, and I'm going to get there. I hope you can all see my screen here. It shows Google. What I can do is just search for NASA Worldview, and I'll click on the first link here. And let's see. So it comes up with the tour here. I'll skip the tour since I'm here to give you the tour personally, but you can feel free to take that yourselves if you like. Let me see if I can make my window bigger here to fill up the screen. If this still works, if it'll break. All right, I think that worked. All right, so let's see. So this is a web app. So like I said, you can go to this URL at the top, and that lets you view it on your desktop, your laptop, your tablet, and your phone. So all the imagery within here is served by freely available imagery services called GIBS, the Global Imagery Browse Services, which you can connect your own client to. And actually, Diane will talk about that briefly after this talk. So let's see. So all the imagery in here is available within 3 to 5 hours of being observed from the satellite. So what you're looking at here is actually imagery from our Terra satellite, from the Moda instrument from today. So I can zoom out here a little bit, and the reason why half of the world is covered is because, well, we've only observed half the world so far today. The satellites orbit from north to south or south to north, so that's why you have these sort of vertical strips here. There are some data gaps in between near the equator, which is where the satellite swath doesn't cover on a daily basis. But that gap basically shifts from day to day. So over time, you get the full Earth. So anyway, this is what the Earth looks like today, or at least the eastern half of it. So I can start to zoom and pan around like you would in Google Maps. I can double-click to zoom or use these zoom buttons in the upper right. I'll turn on some extra layers here. I'll turn on some borders, and I'll turn on some labels. And I can zoom down to, in this case, Egypt and Cairo, and now River Delta. And the maximum resolution of this particular instrument and this product is about 250 meters per pixel. So this is as far as you can zoom in this case, for this product. I can zoom back out here. Let's see. And what I'll do is I'll zoom over to tie it back together with what Diane showed earlier. I'll go to yesterday, and so we have all of the imagery from yesterday. She showed a rapid response ash plume, which I can also show here in Worldview. This is over in Northern California near Lake Tahoe and Yosemite. And you can already start to see that there's some smoke, both smoke and clouds in this case. This is yesterday's imagery. So I can go back a little bit and look for a clearer image. Here's some more smoke. Similarly, I can turn on some fire layers. So what I'll do here is turn on the fire hotspot points here, and you should start to be Okay, I'm back. Apologies for that. All right, so let's see. This is the King fire that Diane referenced earlier, looking at it from a couple of days ago. So you have these time controls on the bottom of the screen, and you can basically drag those from day to day and watch how specific events unfold over time. So I'll go back, and I believe, let's see, I guess I can just keep on scrolling back to see when this particular fire started here. It was about a week ago on September, like 14th is the day it started. So I can drag this time slider, and you can watch how this particular fire grew over time, up to and including yesterday. So some other things we can do. So these are some of the basic layers. This is corrected reflectance from Modis along with the fire hotspot product. We can also look at things in alternate band combinations. So these are different electromagnetic wavelengths that look at things in different wavelengths. So in this case, we're looking at a false color image of the fire area. And green in this case represents healthy vegetation, and the red and brown darkish areas represent burned out areas or actively burning fires. So in this case, you can see there's a pretty large area that's burned out from the fire, especially if you compare it to the size here of Lake Tahoe here, you can get a sense of the scale. If you want to then, I'll turn it back to the true color here. If you want to get an image that you can download and put into Google Earth or your GIS client, or share it with friends, however you want to do it, you can click this camera icon in the upper right corner, drag out an area that you're interested in, move the box around. You can choose the resolution that you want to get with that image, up to and including the highest resolution we have here. You can choose the image format. Oh, and I guess on screen it's not showing you these drop-down boxes, but you'll have to take my word that they're showing you some things here like In this case, the format has JPEG, PNGs, GeoTIFFs, or KMZs. I can click download, and what you'll get then is a separate image that you can use how you like. We've got a free and open data policy, so you can use that however you like. I'll go back over to the demo here. Additionally, if you want to download the underlying HDF data that was used to create this imagery, you can click this download tab, which Diane briefly demoed. What that'll do is it'll search for the relevant data, and once it figures out which data was used, in this case, it'll show two different orbit tracks in the satellites, and these are the granules, they're called, that make up the data of this area. I can click on those granules. I can change the data if I want, and then click download, and then I can download those binary data files and use them for further analysis and whatever tools you like. So let's see. You can also look at the poles, as Diane mentioned, so let me quickly demonstrate that. So in this upper right corner, you've got this globe icon. Right now we're looking at a standard geographic projection, but you can also look at both poles. So here's what Antarctica looks like as of yesterday. Let's see if we have anything for today. We have half of Antarctica today so far. You can also go up to the North Pole. Here's what the North Pole looks like today. And one application we were just informed about a couple of weeks ago was the National Weather Service in Alaska uses Worldview to look for sea ice to help to navigate ships that are in that region. So what I can do is I can start to zoom down into, let's see, let me go to yesterday. So it'll be completely filled in. To kind of twist your brain a little bit here to think about Alaska, rotated about 45 degrees. And let's see. So in this case, I can get all the way down to, this is Nome, Alaska. And well, right now there's no sea ice, but if I go back to April or earlier this year, you can see that there's quite a bit in this area. So if you're trying to plan when to get ships in and out of there, you can change the time, look for the sea ice as it starts to dissipate. And I believe if I go up to May is finally when it clears out, starts to thin out there near Nome. So who knows, maybe that's good enough to get an icebreaker through. I don't know if you trust my advice, but I'm sure the National Weather Service forecasters would know better than me. So, and finally, one last feature I wanted to demonstrate was if you wanted to then share this link or any other view that you're looking at, you can click this link button in the upper right corner. You can get the full link or shorten it down, and then you can copy that, paste it into a new tab, and that will bring you right back to what you're looking at. So those were two application areas, fire and ice in this case, but Worldview also supports the other application areas that Diane mentioned, like flooding, air quality, dust storms, ash and smoke plumes. We currently have imagery from the year 2012 through the present, and one of our big goals right now is to ingest and serve everything from the year 2000 through the present. So you'll be able to see every day between the year 2000 and today. If you're a developer and you're interested in the source code, this is open source Worldview, and you can go to GitHub and find it there and build it yourself or modify it or work with us on it. Otherwise, I encourage everybody to give it a try. It's openly accessible, so if you have any questions or feedback for us, there's an I button in the upper right corner. You can send us feedback up there. So that's all I have, and I'll turn it back to Jennifer and Diane.
Okay, thank you, Brian. So we're now back to the PowerPoint presentation. Diane?
Thank you. Thanks, Ron.
Sure. Thank you.
Okay, so that was Worldview, and on the back end of Worldview, all the imagery is provided by GIBS, or these Global Imagery Browse Services. So as you can see here on the screen, GIBS is a core ESDIS component which provides scalable, responsive, highly available, and community standards-based set of imagery services. Put simply, GIBS serves the imagery to any internet-enabled clients through standard imagery services. So Gibbs ingests the imagery, creates full resolution mosaic layers, and these layers are then chopped and stored as imagery tiles in predefined zoom levels that Gibbs then serves through standard imagery access services. And Gibbs is available in multiple map projections. For the global view, it's available as Geographic and Metadata, and then there's also the polar stereographic projections. Gibbs is very well documented. You saw the landing page for Gibbs on Earthdata in the previous slide. This slide shows the wiki for Gibbs, and you can access this wiki page, and on here you'll find information on the imagery products. There's code for developers. There's information on the tips on how to get Gibbs into map libraries, such as OpenLayers and Google Maps. And there's tips on how to use Gibbs in imagery viewing tools and GIS systems. So some of the tools that support this access include Esri's ArcGIS, ArcMap, Intergraph Geospatial Portal, CartoDB, and Google Earth. And you can find a full list on this wiki page. And just to give you an example of how you can pull the data in, so this is one that I did earlier using the help on the wiki file. So this is ArcGIS Online. So if I want to add in one of the Gibbs imagery layers, in this case I'm going to add in the Moda aerosol product. So I go to the top left-hand corner. Here we are. Let's see. And I'm going to add a layer. I'm going to add a layer from the web. I'm going to select a tile layer for the surface. And then here, I'm again using the wiki. I'm going to type in the URL, or copy and paste the RESTful Gibbs WMTS, the web map tile service. So this is going to provide me with the data from Moda's Terra. I'm going to complete the title and the credits, and then click on Add Layer, and then the data shows up in my map. So it's very simple to get the data in. Okay, so we've mentioned a number of different applications for near real-time data. This slide just shows some of the icons for some of the organizations that use our data. So there are a huge range of applications and very interesting applications, but too many to go into here, so I'm just going to mention a few. So the G20 Global Agricultural Monitoring Community, or GeoGLAM, use near real-time Moda's vegetation indices to provide national and global crop condition assessments. The National Science Foundation, as the weather forecasting service that Ryan was showing, use Lance imagery to provide the latest ice conditions to ships and research vessels in the Antarctic to help them safely plot their course through icy waters. Near real-time imagery from Moda and AIRS are used by various organizations monitoring air quality. They track the propagation of toxic gases like carbon monoxide from fires and use it for health advisories. The Volcanic Ash Advisory Centers use near real-time sulfur dioxide and aerosol index from OMI to monitor volcanic clouds and gases that are released into the atmosphere during eruptions. And this information is used to provide advisories to airlines. We also have several conservation groups that use near real-time Moda's fire data to warn of fires in or around protected areas. And the list goes on. Perhaps applications of Lance data could be a topic for another day. But I'm going to finish with this last slide, which provides some links, which will enable you to access some of the websites that I've been talking about. Thank you. Over to you, Jennifer.
Okay, thank you, Diane. What we'll now do is move to our final set of polling questions. We'll give these just a couple of minutes or so. Be sure you stay in the room and or stay on the line, because we will take our question and answer period directly following these polling questions. And remember that we will not be using the raising hand function, and we will not take them verbally, since we've got a really large audience today across the an international community. So what we'll do is we'll take the questions by way of the Q&A pod. So let's give these just a couple of minutes. Thank you. Okay, I'm going to give this just a couple more seconds here, and then we're going to go directly to the questions. I don't see too much activity. All right, everybody, let's move to our question and answer period. And just give me a moment. Here you do see that the recording for this webinar, by the way, will be posted to the tinyurl.com Earthdata webinar site, as well as to our YouTube channel. So the Earthdata webinar site is more so an online catalog, not only for upcoming events, but also for all of our archived webinars that date back to the end of May 2013. Okay, and we also have a Facebook, a Twitter, and a Google Plus account. So let me go through here and find our first question. You could just bear with me. We'll scroll down, I believe. Okay, so the first question, and Diane or Jeff, whoever would like to answer this question, that's fine. The first question is from our do you have API for automated download products? Diane or Jeff?
Or Ryan, I guess I can try to chime in. I mean, so there's a long answer and there's a short answer. The short answer is right now the quickest API we have is for Gibbs, which is the Imagery API, where you can get imagery back either from a script if you want to write a script. You can get it back through mapping clients and GIS clients. In terms of getting the data directly, Moda has some data APIs, like web coverage services. I'm trying to think what else they have. Jeff, can you help me out on that one? No? Okay.
No.
All right. So sorry, the best we can give you right now is, yeah, if you go to the Gibbs site and you want imagery, you can try that. Otherwise, Modaps has a web coverage service. There's also OpenDAP. Unfortunately, I'm probably not the right person to answer this question, but yeah, there's also OpenDAP kind of services that are available as well. I don't know many details about them, though. Sorry, I can't give any more details.
So I think the thing that we could do for that question, Artur, is that we can also follow up offline with you in an email, okay? I don't know, I think that might be helpful with some of this information repeated back, okay? Sure. So our next question is, how can I download historical fire events for South America, for example, from 2004 to 2014?
Okay, I'll answer that one. You can use the firm's download archive tool. So if you go to the Near Real-Time webpage and click on firms, in the first icon you'll see download fire data. If you go to the archive tool, you'll be able to use our tool there to download the data. It's very similar kind of look and feel to the email alert subscription that I showed. So you should be able to zoom in on a map, and then you can select the date that you're interested in. We do have, if you select too many fires, it will tell you that you can't download them, in which case you might need to split it by year. But you'll be able to get all the data from there.
Okay, thank you, Diane. Our next question is, do you have NDVI images in Gibbs?
The answer is not yet, but it's coming. Both for the historical record, we will, during the Collection 6 reprocessing, we will have the standard science product 16-day NDVI imagery available. The time frame on that is probably sometime in the next year. For the near real time, it is available as data right now, but not yet as imagery. But there is a daily 8-day composite, or what we call a rolling 8-day deposit. So every day they make a NDVI image composite over the last 8 days. that is currently available. I'm looking at Diane in as data in in Lance, and we expect to have it in as imagery in Gibbs probably. I'm just going to speculate in a couple of months time frame. Going out on a limb here, but okay.
All right, thank you, Jeff. Our next question is, what is the plan for extending the time series before May 2012 on Worldview?
Okay, so at the moment, we're on Moda's collection 5. So for all the Moda's data, and collection 6 reprocessing is about to start. And as that goes forward, we will start to populate Worldview. So as the data becomes available, but we don't have an exact time frame for that. So you probably will start to see data appearing in the next 3 months.
Yeah, hopefully.
Okay, fantastic. Thank you, Diane and Jeff. Our next question comes from Kim. What language is Worldview written in?
I'll take that one. It's primarily JavaScript. So it's all front-end stuff using common libraries like jQuery, and OpenLayers is the mapping library right now, or OpenLayers version 2 right now, and we're looking to go to OpenLayers 3. So there are some tools that it uses to build the actual software and then deploy it, but primarily, or exclusively I should say, it's JavaScript.
Okay, thank you, Ryan. Our next question, is there any possibility to get nightlight data in near real-time data?
We don't have any immediate plans to do that. It is something that we would like to do. I guess watch this space and perhaps drop us a line and we can try and keep you posted.
I assume that the person is referring to the VIIRS VIIRS day-night band. And we have like 1 year composite available in Gibbs and Worldview, but there's VIIRS in Lance and Worldview /Gibbs is something that's probably going to happen, but there's quite a long time frame for that. We can't really give you any. We can give you hope, but not much in the way of specifics. Sorry.
Yeah, but as Diane mentioned, there is right now, if you're interested in seeing a global cloud-free composite of nighttime lights from 2012 that exists right now in Worldview as the, I think, Earth at Night layer it's called.
Okay, great. Thank you, Ryan. Our next question comes from Tim. Can you add fire perimeters to your maps available from GOMAC folks, parentheses, USGS?
That's a good question. Perhaps it's something that we'll look at for the future. We don't have any immediate plans to do it. We try to make sure that all the data we provide is global, and we don't have that data available globally. As you quite rightly point out, for the moment it's available for the United States.
It says perimeters though, so is it like shape files? Can you add a shape file to determine what your extent is for your alerts? Is that something you can do in Firms right now?
You can add a shape file to, yes, for your email alerts, but
okay.
That's not the same as a fire perimeter.
Oh, I see. Okay, I apologize, yeah. Okay.
But if we haven't answered that question properly, then please feel free to, we'll contact you by email to make sure that we've covered that.
Okay, our next question is, do you have any apps for iPhone or Android?
So you can use Worldview on an iPhone or Android just in your web browser, so in Safari or Chrome or whatever. And it works reasonably well, I think. I mean, if it doesn't, then you can let us know. There are a couple of third-party apps that have been developed, and we encourage, if there are interested developers out there, to build an app using Gibbs. But there's a couple that exist right now. There's one called The World Daily, and there's another one that was just created a few months ago, which I'm blanking on what the name is right now. I'll have to look that up and get back to you in a second, but I don't have that offhand.
Okay, and then the next question is, does Lance near real-time data, is Lance near real-time data available for all geographical locations with the same quality?
Yes, I believe, yes. The quality would be the same. As Diane mentioned during her talk, there are some differences between the science data and the near real-time data. But those in like sometimes there's geolocation issues with a maneuver or space weather, but those are specific for those happen in certain locations for that particular event. But other than that, the quality is the same worldwide.
Okay, thank you, Jeff. The next question is from Bill. Is there a capability for infrared fire view when cloud cover presents direct view via LANS? So the question is...
Yeah, I mean, the Moda's fire algorithm takes advantage of several of the bands in the infrared bands, and so in some cases you can see you can see fires through thin clouds, or for example that volcano in Iceland right now is so hot it's actually showing through some fairly thick clouds. But in general, the answer to that question is no.
Okay, thanks, Jeff.
Jennifer, let me just jump in 1 second here. I did find the answer to the Android and iOS app question. Which was,
Sure.
There's an Android app called Fire Mapper, which was just created this summer. That's for free on the Google Play Store.
I'm going to go ahead and enter this into, you said Fire Mapper?
Yep. That was created by, I believe, some interns at Raytheon.
All right, I'm going to put this out there to everybody. Okay, so the next question, thanks Ryan. The next question is, and we'll take a couple more minutes of questions since, we had a little bit of lapse in time here. I'll go ahead and extend it a couple more minutes. How often for any given point on Earth is data imagery being acquired and made available?
For the Moda imagery, Moda flies on 2 satellites, Aqua and Terra. Terra comes over nominally 10:30 a.m. Local time. Aqua comes over nominally 1:30 p.m. local time. So with the visible bands, you're getting 2 looks a day. And again, at the equator, it's not quite every day. So probably 14 out of 16 out of the 16-day orbit cycle. For example, for fire, and the satellites collect some of the data at nighttime. So for example, for fires, you're actually getting 4 looks a day. You're getting Aqua and Terra at the daytime and Aqua and Terra at nighttime.
Okay, great. The next question is, and it comes with a bit of an explanation. I'm currently using Modis data to detect dust aerosols in near real time through LANS. The question is, what acknowledgments or credits should I give to LANS? So I guess this, they're asking about a citation policy for LANS. Do you have one? Do you have an example, and where can this information be found?
We do have a citation policy. We ask that all imagery is credited to NASA LANS, and you can find that on the frequently asked questions on the near real-time data page. We can send a link for that.
And is that link is going to be lance.eos.nasa.gov?
It would be earthdata.nasa.gov/LANS, and then
okay, and then go to frequently asked questions.
Yeah.
I'm going to go ahead and type that in for everybody here. All right. Okay. Next, are there any license considerations if used with a business applications? Are there any limitations on the use of imagery in reports, etc.?
We've got an open data policy, and so no, there really aren't restrictions. We would ask that you do cite us, as Diane mentioned, but no, it's free and open.
All right, we're going to take a couple more questions here, and then what I'll do is I'll leave the meeting room open for a few minutes for those of you interested in downloading the slides. I would note that there is I need to still upload a final set of slides here, so for those of you who wish to stay in the room for that, you can. Otherwise, you can download all of these slides by listening to the recording once it's posted. So no worries, this feature is actually persistent, the file sharing pod. That can still be accomplished after the webinar is complete. The next question is with regards to any plans to include Landsat data down the road.
So I'll take that one. And so the short answer is yes. but it wouldn't be in near real time, and it's a particular product that NASA works on called the Landsat Weld product, which is the web-enabled Landsat data, which is basically a composite of Landsat scenes to build up weekly, monthly, and annual composites of the best pixels that are available from Landsat. So that, and that'll be full resolution. That's about 30 meters per pixel, in some cases 15 meters per pixel. But we're in the very early stages of that, and that's a ways off. But we're excited whenever that is, when that will be available. That's not near real time, no, that's correct, yeah. But I should mention, actually, that will go back, it's not too straightforward to explain, but it'll start around 1980, I believe, and run through the present, but it'll be about 3 to 6 years per decade. So you won't get all, whatever that is, 40-some years, 30-some years. But you'll get basically a sampling of imagery from 1980 through present.
All right, thanks so much, Ryan. Just a couple more questions here. And then the next question is, any plans to include PODAC data, for example, JSON 1, 2, or 3 related data sets?
Let's see. So I don't think we haven't started working with JSON. We are closely working with PODAC, the Physical Oceanography Data Center, on some products, including the sea surface temperature, and well, chlorophyll comes from our ocean color group. We also have that right now. We haven't started talking about JSON at this point. If you have any other ocean products, Jeff, that you want to mention?
Can't think of any.
Not offhand, no.
But there are near real-time ocean products available through PODAC.
Oh, okay.
Okay, just 2 more questions, and then what we'll do is if any of the presenters would like to stay in the room and answer questions by way of the Q&A pod, we can do that. So is there any documentation on APIs or web services for programmatic access? Please distribute where to find it.
Sure, we can send out a link to Gibbs. There's an API page for getting to the imagery, including how to create a script that you can programmatically pull imagery. I'll send that out in the Q&A link here right now. Let me find the link and send it. In terms of getting to the data, we can maybe go offline on that. Like I said before, we do have some scattered web services to get to the data itself, but those aren't centralized like Gibbs is.
Okay, thanks, Ryan. I'm just going to take one final question from Dane. Do you have products for oceanographic features?
Yeah, I'm not sure what, not quite sure what oceanographic features. We do have there's a sea surface temperature, which is almost near real time in Gibbs, and there's chlorophyll in near real time from the ocean biology color group, whatever.
Ocean biology processing group.
Yeah, thank you. But those are the only 2 right now. There are some, there is discussions about some of the, other ocean science layers to be added to Lance and Gibbs in the future, but I don't have a lot of detail on that at the moment.
So Dane, just to follow up with that question, if you are looking for physical oceanography or ocean color data products, there are 2 data centers that have, well, there are 2 data centers that, primarily focus on those products, and we can certainly follow up with you offline. I don't know if you were really more specifically addressing any layers available within the Worldview tool. If that's helpful to you, please email me and let me know, and I can put you in contact with the user services at both of the data centers. Provide you with some links and resources. All right, well, that is going to be our final question for today. Please feel free to enter any more questions in here, and we will have our speakers answer those by way of the Q&A pod. I will leave the room open for an additional 10 minutes or so. I wanted to thank all of you for joining us today. Thanks for standing by while we had a lapse for a minute or so, and perhaps I will see you again in an upcoming webinar. Also, I wanted to add that we do have an email announcement listserv. If you are interested in receiving upcoming webinar announcements, you would go to the tinyurl.com Earthdata webinar, and there's a link at the top of the page on how to sign up for our email announcement, listserv. And then we do have a webinar tomorrow dealing with DayMet climatological data products at the Oak Ridge DAC, and then on October 8th we will be holding a Landsat data discovery and data access webinar, which will be posted this week. All right, so connect with us on our accounts, and thanks for joining us. At this point, I will log off the telecon, so thank you so much. All right, bye-bye now.